Hello everybody, this is Chapter 3, Section 4, Product Rule and Quotient Rule. So as we talked last section, there was no rule that you had for multiplying two functions together. You had adding two functions, subtracting two functions, you had a constant times a function, and you had the power rule. But now we're going to get the product rule and quotient rule. So theorem 3.7, this is the product rule. So you have two functions that are differentiable, and they're being multiplied together, and you want to take the derivative. Well, this is actually pretty easy. You take the derivative of one of them and leave the other alone. But then you leave the one that you took the derivative of alone this time, and you take the derivative of the other, and you multiply them. And then you add those together. Now you could do this in any order, because addition is commutative. It doesn't matter which one goes first. You just have to have both of them there. So pretty simple rule. Make sure that you follow it. And we have an example. I'm going to do it two ways. I'm going to do it the easier way, and I'm going to use the product rule. So let's start with the product rule. So the derivative, you leave the first alone, and you take the derivative of the second. Well, the derivative of that, let me rewrite this so it's not too, I didn't even rewrite it. What am I thinking? So it's a little bit easier. We're going to use the power rule to that. So the 1/2 comes in front, and then I decrease the power by 1. So 1/2 minus 1 is negative 1/2. And the derivative of 1 is 0. So that's leaving the first alone and taking the derivative of the second. Now I take the derivative plus of the first. Power rule, I bring the 2 in front and subtract 1 from the power. I get 2v. And I leave the second alone. Now that needs to be simplified because it's kind of ugly. Well, that 2 and that 2 cancels. So let me do some very basic work. That's going to get us v to the negative 1/2 plus, I'm going to distribute this. They all have a v in there. Actually, I shouldn't, but oh well. So it's going to be 4. I don't know why it's all red. Weird things are happening. So 2 times 2 is 4. V, how do you do those? You need to know the rules of exponents. That's a 1, that's a half. If you multiply two exponents, same base, you add the exponents. That's going to be the 3/2 power. And I distribute the 2v. I get 2v. Now, I need to add these. I add the exponents just like before. I'm going to get 3/2 again. Now, there's a couple things that are going to happen here, but first of all, I have 1 of those and 4 of those. How many do I have? I have 5 of those. And that's going to be the answer right there. So in other words, you could factor that out. You're left with 4 plus 1, 5. That's an acceptable answer. If you want it more simplified, they both have a v. We could take the v out and be left with 5v to the 1/2 plus 2. But either answer is fine. We'll leave it like that. So that is using product rule. In this case, it actually would have been easier to not use the product rule. It would have been easier rewriting and then take the regular derivative. So what I could have done instead, I could distribute that. So this is v to the 1/2 power and a 2 power. You add those, so it's v to the 2.5 power, which is the 5/2 power. And I have a v squared. Okay? Now we use the power rule. You bring the 5/2 in front. You decrease the power by 1, so 5 halves minus 1, that's going to be 3 halves. And using the power rule there, I get that. And then these 2's cancel. This was much, much easier. 5v to the 3 halves plus 2v. So sometimes it's easier if you rewrite it. Sometimes it's easier doing product rule. It just depends, and you'll get a feel for it. The second example, I can't rewrite it. I can't combine these because they have different bases. So my only option is product rule. So what is the product rule? I leave the first one alone, take the derivative of the second, but what is the derivative of e to the x? I am my own grandpa, so it's just e to the x. Then, now I take the derivative of the first one, x squared, and leave the second alone, it's e to the x. What's common to both? They both have an x, and they both have an e to the x. I will take that out, and I'm left with x plus, whoa, they both have an x squared? Did I mess up? I messed up. Let me back up. I really messed up. So for the first one, I left the first alone, took the derivative of the second. Now I'm going to take the derivative of the second, which is 2x, and leave the second one alone. So first I left it alone, then I took the derivative. This I took the derivative, then I left it alone. So they both have, excuse me, an x and an e to the x. So I took that out. For the first one, I'm left with x. The second one, I'm left with 2. And that's going to be my answer. That's it, as simple as that. Here's your next theorem, theorem 3.8. You have two functions, again, that are differentiable at x, and the denominator is not 0. This is the quotient rule. So I'm going to call this one the high one. I'm going to call this the low one. So here's how it's going to be. Low, because g is the low one, right? F prime is the derivative of the high, so I call it low d high. I have a mistake in here. Oh no, that's a minus. That's a minus. Whoopsie, whoopsie. Minus f here is the high function, so I'm going to say high. G is the low function. I want the derivative of low, so d low. And this is the low one squared, L squared. So low d high minus high d low over low squared. That's just something I use to help me memorize what it is. You can say this. The low D got high. If you don't know what a low D is, it's someone who gets loaded by drinking or taking drugs. So the low D got high and high D was low. Now I once had a student, her name was Heidi, and she was really short. Really short. And so high D was low, all over low squared. However you memorize that, you just have to memorize it. There's not a whole lot you can do with that. All right, let's go and apply this. So the first example, I want the derivative of that function going, well, the top function divided by the bottom function. So I want low d high. Well, the low one is x squared minus 1. D high, I need the derivative of that. Using the power rule, I get 2x plus 3 minus, and then I need high d low. Well, the high is all of that. D low, the derivative of that is 2x, the derivative of that is 0. So d low be 2x all over low squared. Now it's going to be lots of algebra. I need to distribute that x there and there. That's going to give me 2x cubed plus 3x squared. I have to distribute the negative 1 there and there. That's negative 2x minus 3. Then I'm subtracting this whole thing. So I want to make sure I bracket this. So I need to distribute the 2x to all three of these. That's going to give me 2x cubed plus 6x squared plus 8x. And all of that is over x squared minus 1 squared. Then I have to distribute this. And then that will give me this, 2x cubed plus 3x squared minus 2x minus 3 minus 2x cubed minus 6x squared minus 8x. This is getting ugly. Let's look for nice things to happen. Look at that, 2x cubed minus 2x cubed, those cancel. I like that. And then I have positive 3x squared minus 6x squared. If you combine that, that gives you minus 3x squared. And I have minus 2x minus 8x. That's going to be minus 10x. And then I have minus 3. So just minus 3 all over x squared minus 1 squared. That's it. That is your answer. We have found the derivative. Okay? And that's using the quotient rule. Now, before I did that, I would have seen if I could simplify that. I know that factors the x minus 1, x plus 1, but the top really doesn't factor, so you're stuck. It doesn't simplify, so that's the easiest way. All right, this one's weird. When we do the section 3.6 chain rule, there's a shorter way of doing this, but as of now, there's really no shorter way, so I rewrite that as 1 over e to the x. I have a quotient. There's a function, there's a function. So I can do my low d high minus high d low over low squared deal. So the derivative of y with respect to x, let's look at this pattern here. I take the low and the derivative of the high. The low is e to the x, and the derivative of a constant is 0. Minus high, high is 1, the upper function is f of x. D low, the derivative of that, I am my own grandpa. That's going to be, e to the x all over low squared. Well, 0 times anything, 0. And let me do some simplifying. It's going to be minus e to the x over e to the 2x. How does that work? Well, maybe I should make it look different for you. So the rule is an exponent raised to exponent, you multiply those, so you get 2x. But you could also just write it down twice. One of these cancels, and I get negative 1 over e to the x, which is negative 1 e to the negative x. Either one of these are fine, but that's the next example, and that's going to be quotient rule. All right, that's pretty much the lesson. We just want to do some more examples of these. So we have 3 more to go. Here we see a quotient, something on top divided by a function on the bottom. So we're going to go through the same process. Now you should try these on your own. Pause it here, then compare your answer to what I get. All right, welcome back. It's low, which is the bottom one, d high, which is 0, minus high, which is the top one, d low using the power rule, I get that, all over low, which is the bottom one, squared. That's just 0. This is a pretty quick one. 9 times 5, that's negative 45, x to the 4th. The rule exponent raised to an exponent, you multiply that, it's x to the 10th. And then 4 of those will cancel 4 of those, leaving 6 on the bottom, right? So it's negative 45 over x to the 6th. That's going to be your answer. Pretty easy peasy, fresh and easy. 2 more examples and we are done. So for the next example, we again have a quotient rule. Now I'm going to rewrite this another way. And actually, it's not going to make life easier. So maybe I won't. I might just talk about it. But low is the denominator. D high. That, the 16 comes in front. That's going to be 48. T, decrease the power by 1. And the derivative of 4 is 0, so that's gone. Low D high minus high. I'm going to copy the top. And the derivative of the bottom, using power rule, is 6t to the 5th. Whoa. 6t to the 5th. That's really scrunched. All over the bottom one squared. 48 is going to stay. Keep doing that. Whoopsies. So 48, you add the exponents, that's 21. So it's going to be t to the 21. And then a couple things are going on. I'm doing 2 things. I distribute the negative. I distribute the 6t to the 5th. And what happens? The negative gets me a minus. 6 times 3 gets me 18. And it's going to be t to the 21. Now that minus becomes a plus. That's going to be plus 24t to the 5th. And on the bottom, you multiply the exponents as to the 12th. All right, 48 minus 18 in my book, that's 30 of them. That has a 2. That has a 2. T to the 5th is the highest power. So I'm going to factor that out. Hopefully I don't make a mistake here. So 2t to the 5th. I'm going to be left with 15 t to the 16th and 12 all over t to the 12th. And 5 of these guys are going to cancel out with 5 of those, leaving 7. And hopefully that's the right answer. So I'm going to have 12 t to the 16th plus 12. That's not 12, it's a 15, bro. All over t to the 7th. Let me check that answer. Okay, they simplified it. I'm going to make sure I have this right. That's 30t to the 9th. Perfect. 24t to the negative 7. Okay, so the book did this, distributed that, got 30t to the 16th minus 24, or plus 24 over t to the 7th. Then we divide these individually, and that's their answer. Will be 30, 16, and 7. 7 of those cancel out, leaving 9 of them. So they had a t to the 9th and 24 over t to the 7th, which all of you should know is 24t to the negative 7. That answer's okay, that answer's okay, that answer's okay. Any one of those is fine. Just make sure you know how to manipulate back and forth between those, all right? All right, one more example and we will be donesies. A couple of things are going on. We see a quotient right there, but we see a product right there. Which one do we do first? We're going to take the derivative. I don't know. For me, I just see one big blob divided by one big blob. And as we do this, we'll take care of all the issues one by one. So we'll go through this. Now, somebody say, how do you know you don't do the product rule first? Because we're dividing that by that, you do the quotient of that big thing. I don't know what else to say. So I'm going to do low, which is the bottom. D high, here's the problem. What is the derivative of the top of that? So we're going to do side work. I'm going to call this f of x. And I recommend doing side work because it's less confusing. If you try to put it all together, it can get confusing. So this is the derivative of the high, or the top one. And this, you'll notice, is a product. The product says, leave the first alone, take the derivative of the second, plus take the derivative of the first, leave the second alone. So there is the product. I want the derivative of the high. That is the derivative of the high. So I'm just going to copy that down. So that's low d high. I still need minus high d low. So the high is 4x e to the x. D low, the derivative of x squared is 2x. Derivative constant is 0. So that's just going to be 2x all over low squared. Now it's time to simplify. I'm distributing the x squared, giving me 4x cubed e to the x plus 4x squared e to the x. So the only difference is x squared and x give me x cubed. All right, next I'm going to subtract, and I multiply these two together. So 4 times 2 is going to give me 8x squared, because x times x gets you x squared. And we have e to the x all over x squared plus 1 squared. Not bad. All right, can we combine any like terms? There's x squared e to the x, there's x squared e to the x. I have 4. You take away 8 of them, that's going to be minus 4 of them. And then we're going to do a little bit more work here. Let's look for what they have in common. They all have a 4. They have x squared in common, and they all have an e to the x. So let me take those out. They all have a 4, they all have x squared, they all have an e to the x. Well, if I take out the 4, e to the x, and x squared, I'm left with 1x. Take out the 4, I take the x squared out, I take e to the x, that's everything, minus 1. I believe that's the answer. I believe maybe not. I think I made a mistake because that's not what this... OMG. Let me back up. I'm not going to redo this video. Let me see what's going on. Oh, I know what I left out. My apologies to the chef. My apologies. I totally forgot to distribute the 1. That's going to mess everything up. So let me get to that point. I distribute the 1. I'm going to get this and this. Then I'm going to get all that. So that's going to be minus 8x squared e to the x. So I was just missing those pieces from distributing the 1. Everything else should have been fine. So I still have 4x cubed e to the x. And then again, we're going to combine those and those. I have 4, take away 8. I'm going to owe 4 still. Minus 4 x squared e to the x. Let me make that prettier. And then I have all of that. All over x squared plus 1 squared. All right. Can I do anything else? Well, if you look, they all have a 4. So I can factor the 4 out. And they all have an e to the x. I can factor those out. They don't all have an x, so I can't do that. I'll be left with x cubed minus x squared plus x plus 1 all over x squared plus 1 squared. I think that's the right answer. It matches up with what I have. So that's it. That is a combination of quotient rule with the product rule and part of the problem. All right. Have a great day. Bye.